So most people, when they think about tiny atomic-sized particles in nature, they think about atoms and they think about molecules, and they forget about ions. Don't be one of those people. So the chemistry book that I am referencing for this playlist, Chapter 2 is titled Atoms, Molecules, and Ions. Ions are as much of a fundamental particle in nature as are atoms and molecules. I will admit, though, that ions don't occur nearly as naturally or on their own as atoms and molecules. But still, don't forget about ions, so let's talk about them now. Okay, so an ion is an atom that has lost or gained one or more electrons. Okay? I didn't say proton. If an atom loses or gains a proton, then the atom is different, right? If an atom loses a proton, then it becomes a different atom with an extra electron. So when we're talking about ions in chemistry, we're talking about gaining or losing electrons. The atom stays the same, but becomes charged, positively or negatively. Okay, let's look at the sodium ion. Sodium loses an electron, and notice how ions, the size changes. If you lose an electron, size gets smaller. The sodium ion, the Na plus ion, is smaller in size than the Na atom. The chlorine minus ion is larger than the chlorine atom because it gains an electron, right? Notice before, the sodium atom is bigger than the chlorine atom, but when they're bonded in a crystal to form NaCl, salt, the sodium ion is smaller than the chlorine ion. So remember that. Remember how the size changes with ions. Okay, a positively charged ion is called a cation. A negatively charged ion is called an anion. And again, notice the name. The sodium, it's still sodium. Chlorine, it's still chlorine. The number of protons has not changed. It's just now chlorine ion, sodium ion. These two ions form an ionic bond. Ionic bonds create these crystal structures. Okay, there's also polyatomic ions. So for example, ammonium ion, sulfate ion, right? Polyatomic, multiple atoms. Okay, so another point to note, remember that ions have very different chemical properties than do the original atom, right? NaCl exists as salt. Sodium, for example, is a soft, highly reactive metal. Soft, shiny metal. It's very different. Think about it. Chlorine, I believe, is a gas, or it might be liquid at room temperature and pressure. But these ions combine, form salt, something that we eat. We surely don't eat metal, and I'm pretty sure we can't ingest whatever natural chlorine, pure chlorine. So very different chemical properties. Ions and their atoms, corresponding atoms, have very different chemical properties. Okay, note that in general, metals form cations, non-metals form anions. And that's just because that elements tend to want to get to the most stable, that noble gas configuration. So group 1 tends to want to lose an electron to get to that noble gas configuration. Lose 1 electron. Group 2, lose 2 electrons. Group 17, gain an electron. Group 16, gain 2 electrons, etc. Again, just in general. So that's a good starting point to try and predict the most common or stable ion. For like lithium, anything in group 1 here, it'll be the Na plus ion, the K plus ion, Li plus ion. That's most commonly will be formed, right? F minus, O2 minus, N3 minus, Al3 plus. Why Al3 plus? Because it's 3 away, 1, 2, 3, loses 3 electrons, and it gets to this configuration, but it's also a metal, right? So if you look at the periodic table and something's classified as a metal, well, metals lose electrons. Metals tend to lose electrons. Look, carbon's right in the middle. Probably has something to do with why it's at the center of life, living things. Okay, so I briefly talked about ionic compounds. So the chemical formula for NaCl is just NaCl with no subscripts. And so if you want to try and predict the chemical formula of an ionic compound, take a look at the charges of the 2 ions. So this is Na plus, Cl minus. And all you do is just bring this down bring this down. So that's 1 plus 1 minus 1. So Na1Cl1, NaCl. Let's do barium chloride. If barium chloride formed an ionic compound, what would the chemical formula be? Well, barium loses 2 electrons to get to that noble gas configuration. Chlorine gained 1 electron. Ba1 Cl2. And all this comes from is just the charge of the compound of the compound that's formed is going to be electrically neutral. So for every barium, right, which is a 2 plus, you need 2 chlorides to balance out the 2 pluses. You see? So again, we're just predicting, like, you can have ionic compounds where these 2 original atoms, like the sodium atom transfers an electron to the chlorine atom, and then they bond. So sodium gives its electron to chlorine, becomes the sodium ion, chlorine becomes the chlorine ion, and they bond to create this solid. It's these crystals. Okay? It doesn't have to be just NaCl. Again, we just did the barium chloride ionic compound. That would be its chemical formula. What about magnesium nitride? So that those two could form an ionic bond, form a crystal. So magnesium, it's going to want to give up 2 electrons to get into its most stable form. So its stable ion is Mg2+. If it's going to form an ion, it wants to be Mg2+. Nitrogen wants to gain 3 electrons. That's its most stable ion. Mg3, right? You need this ratio of magnesium ion to nitrogen ions to balance the charge. So this would be the crystal that would form.